Welcome. In this video I'm going to show you how you can perform a Freeman-Tukey-Read Goodness-of-Fit Test using R and the stikpetR library. The version of R that I'm actually using is version 4.3 and it comes pre-installed with these packages. I'm using JupyterLab, but all of this code should also work in, for example, RStudio. I have a separate video if you don't want to use my own library. Now I'm going to focus on how to actually obtain the result, not so much if you should be using this test, or actually it's a family of tests because you can set different weights, and also not so much about reading the output. It's mainly on how to just simply get the results. To show you how this can be done, I need some example data. So I'm using GSS, General Social Survey 2012, and I slightly adjusted it here and there just for some examples. And I don't need all the data, I just only need actually the marital status, which was collected under MAR1, and with the, so I'm saving that as my field, and to get a quick impression of the data we can use the table function from R. And as you can see, these were the counts, and in essence the test looks if these counts could be equal in the population. Now the stikpetR library itself is not available on CRAN, so you will need to use DevTools and install it from my GitHub with this function, or this script command. I of course already installed it, so I only need to load the library. You can, once you've installed it once, you can load it simply like any other library. The function of interest is TS for test, Freeman-Tukey-Read. It takes as input the data. You can also specify the expected counts if you have those. The weights, default will be the default that's also from read 4/3 and 8/3. And optionally you can use continuity correction, either Yates, Pearson or Williams. So simply fill out the function and give it the field, and you get this nice little data frame as a return. The n is the sample size, the k is the number of categories, the statistic is a chi-square value with degrees of freedom of 4, which is simply the number of categories minus 1. The p-value, also sometimes referred to as the significance, the minimum expected count, and the proportion of cells that was below an expected count of 5. In this case 0. These two are because sometimes people have some criteria to use this test. So then you can actually use those to see if the test is valid. The p-value in this case is far below the 0.05 usual threshold, so we would reject the assumption about the population, and in this case would say that there is a significant difference in counts in the population. We could have also provided our own expected counts as mentioned earlier. So for example, if these were your expected counts, you can actually test if those might still be the case in the population. So we feed it the expected counts as a data frame. So these are the categories and these are the expected counts. And once we have those, we can just add that as expected counts in the function, and it simply gives you the results. You can also set the weights differently, for example, like this, and that should give you also same results. And that's how you can actually use this function. If you want to do it without libraries, I have a separate video on all of this, so it can be done where you just follow the formulas, and these are the references. I hope this video was helpful, and thank you for watching.